Okay, any second now.
Mhm.
Hello, everybody.
Yes.
Happens to be episode number 135 of the SBAU Astro Hour for September 18th through the 24th, 2023. For all you stargazers, fans of astrophysics, like members of our longtime telescope club for the south coast of Central California, the Santa Barbara Astronomical Unit. I'm your host, proudly, Ron Heron, former radio guy, now somehow VP of SBAU. I don't know how I got that. Going to introduce you to the beloved members, some very bright and knowledgeable gentlemen I know and work with of our board, some staunch supporters. We have a lot of fun here every week. We've been doing it almost 3 years. Please come and join us on a first Friday of the month when, October 6th, we'll be back in Farrand Hall, the little smaller item area, and watch a man from upstate New York in a little village who writes a column regularly for Astronomy Magazine deliver an interesting report. Here's what we're going to talk about. Primary on the North Star this week, plus our rotational axis. It's just changing. I'm not sure the stars are up there anyway. It's a binary system. Cepheid variables are us. Science uses these to map the Milky Way. Did you know that? The Nishimura comet may have passed, but we got another to look for, several others up there. Going to need a telescope there. It's an up-close look at the Dumbbell Nebula. Don't want to be personal and call it in any names other than what they gave it. Our furthest of the 8 planets, viewable all night long these days. Our waxing crescent moon will touch the red heart of the Scorpion on Thursday of this week. And we're going to celebrate 100 years of a classic New England Astro Club called Stellafane. It's got a pink building. Let's meet the guys and then have some silly cartoons. Hello, Mr. President, Jerry Wilson.
Good morning.
How are you and your lovely wife, Pat Forgy?
We're good.
Supporter and member. And other than battling typical older guy problems, we're going to welcome back our incredible outreach coordinator, Chuck McPartland. Fresh
Morning.
from Ireland. Chuck is also married to a Pat, who is our merchandise manager and uses, what's that stupid vegetable that she puts into her email address? Parsnip, right? Those are like white carrots, aren't they? I believe so.
Close enough.
Yeah, and here's Tom Whittemore, who's married to
Morning.
Maureen. Tom is a former science instructor, had his own lab out at Westmont College. And I think, among other things, let a stupid little silly thing like a pandemic end his career. He's editor of our SBAU newsletter, so that's a new career. And Mr. President does send us via email forwarded silly science cartoons. Last week I totally forgot and went right into this regular stuff, and there's a silly cartoon on the screen, and I apologize for that. But let's find out what he's been sending us. Didn't have too many, but there's enough to have a good laugh and get our hour started, gentlemen. Here they come. This is an alien takes it seriously. Personally, he's being spied on while taking a bath. I think he's still, he's got his towel wrapped around him. He slaps the astronomer. He'll never let that happen again. I don't think they have telescopes like that anymore where you sit in front of the lens. What is this? Oh, this is something that used to happen with our covered dish June SBAU covered dish potlucks. Somebody bring a Petri dish. Ooh, she says, now what dish did you bring? And it's Dr. Petri finding himself invited to his first and only potluck. Those were all little bacterial colonies on there, weren't they? It's
Yeah.
In agar.
Is that how we got penicillin? Something like that, wasn't it?
Yes.
Well,
Yeah.
that was an accident, yeah.
All right. We don't know who did this cartoon, but it's funny. All right. Here we go. I've seen this one before. Kids, what are we going to do with these kids today? Just to show you how things have changed in the academic world. Here a child walks by these two students who says, I was going to tell that kid this is a tech class for adults. Then I was told he's the teacher. For crying out loud.
I went back and visited UCLA after I graduated by several years. And I walked around and my first impression was, how did all these high school kids get into college? They seem to look younger and younger as we get older.
It seems like the whole nation, the whole world is divided between those that know and want to know and those that don't give a darn. Okay, this is being late in the quantum physics world. Guy shows up at the door. You got to know quantum here. You're late, says the professor. And he's over there behind the water cooler going, no, I'm not. I've been here all along. It can happen to particles. It can happen to people with strange little hairdos there on the sides of their face. In the beginning, there was nothing, which exploded. Sir Terry Pratchett said, what is this? Is this in the beginning? It's a brand new biblical version of the Big Bang. We're tying them together in this. It's
He's an author of a number of very good science fiction books.
Okay, and so this happened 6,000 years ago, right? The Big Bang?
No,
Well,
I wouldn't pin it down like that.
That's what the missionaries tell you at the door sometimes. That's funny stuff, which exploded. Now, this is I write little notes about this. The poets, yes, stars were the poets from a poet's view. Poets say science takes away from the beauty of the stars, mere globs of gas atoms. I too, says Richard Feynman, can see the stars on a desert night and feel them. But do I see less or more? Oh, that's deep. Not funny, but deep. Okay, good stuff. Gets us off on a good mood. Okay, we're not going to get any reports from Ireland, but I'm assuming you brought me a pub hat, Chuck, and Pat's feeling okay. And
we considered getting a pub hat, but we couldn't tell what the sizing was.
I got one from my good friend Jeannie West, who went to Ireland. I'd like to go there. Is it green?
Oh, it's exceptionally green. Yes,
Exceptionally
everywhere.
green. Did you
Just
kiss
the stuff that grows along the narrow roads looks like, a garden.
Well, did they hang you upside down to kiss the what stone?
We did not go there. We just
didn't
went
go
to
there.
Dublin,
Galway.
and we went to Birr to see the Leviathan, the biggest telescope in the world for several decades. And
Wow.
then we went to Galway, and then we went to a little town called Clifton and spent a week there, and then back to Galway, back through Galway to Dublin, and then home, and caught contagion on the way home.
Our town had a sister city that was only 5,000 people on the coast. It's the only thing they had in common with us, called Dingle.
We did find in Galway, apparently Dingle is famous for their ice cream. And we found an ice cream store in Galway that we visited a couple of times and got some Dingle ice cream, and it was good.
I heard they had about 5,000 or 6,000 people population, 26 Catholic churches, and 50 something pubs. Well, we're going to talk about Polaris. I didn't know it was the closest, brightest Cepheid variable, and it's not just a binary. I think it's a trinary, isn't it, Mr. President, and the rest of you? Here
Essentially,
we go.
yes.
I think it's a binary, but a visual double.
We can see the two stars that make Polaris.
Easily.
No, you can easily in a telescope, you can see the visual double,
Yeah.
but the binary part is harder.
And Ron, that's a favorite at star parties because you aim your telescope and you don't have to move it.
Yeah.
I
Don't
noticed
use up
that.
your battery.
Well, you might have to a little. It's about 2/3 of a degree off of exact north of our axis pole.
Is it something like that? Yeah, it's less than a degree, I know.
Is
It's
it going
around
away? It's
3/4 of a
coming in.
degree.
It's coming in closer, though, isn't it? I believe over the years to come.
It's coming up toward, in a few years, a few decades, it's coming up toward its closest.
Okay.
Closest as far as north celestial pole, not actual distance wise.
Right, correct.
But every few thousand years, we get a new North Star.
Mhm.
We'll cycle back to Polaris in 25,000 years.
Well, do you suppose it's similar to Proxima, to Alpha Centauri and Proxima, isn't it? That's a threesome.
Well, this isn't a physical threesome, I don't think, Ron.
Yeah.
The Y double is just a chance alignment.
Mhm.
It doesn't have a third companion.
Right.
But they're under different ground rules. The third companion down here, Polaris AB, in this dot. Can you see the post I've got up?
Yep.
Okay. Down here at the bottom, Polaris AB, that's an actual gravitationally bound double. Polaris A and Polaris B are the visual binary, but this is not gravitationally bound.
So the bottom right are orbiting each other like bats in going like crazy. Are they close?
I don't think it's that close. It's not like one of these hot supergiant exoplanets that's going around a few days.
But we don't know yet whether there are exoplanets in the system, the Polaris system, right?
I don't.
We haven't.
I don't think so. I haven't heard that there are exoplanets in it. You know, you pick a given star, and they're basically two methods of finding out whether there's planets around it or not. One of them is to have the exoplanet occult or pass in front of the star. And so that you have to be lined up with its ecliptic. And only about less than 10% of the stars that have exoplanets are going to be lined up that way. And then the other one is to see, as something goes around it, you can see the spectra of the star move back and forth very slightly. The lines will go to the blue and then to the red, showing a Doppler shift as the object goes around. That takes alignment too, but it's not as exact or precise requirement as occultation is. So you can't find everything, at least so far. When we get bigger telescopes, maybe out in space, we'll be able to look at stars and see things going around them.
Well, your notes say it's the closest, brightest Cepheid variable. How close is it? I don't think you posted any miles or light years. Is it within 30
Didn't I?
I'm not sure. Maybe I missed them. I do transcribe lately I've just been putting down the highlights.
I think they think it's closer now than they did before. It used to be considered to be something like 600 or 800 light years away, but now I think the accepted number is like 400.
Mm-hmm.
Okay, and mankind
Ron,
is yes.
Ron, if somebody asks you where Draco the Dragon is, a real nice little trick is, you see the two dippers up there, right? If the two dippers are up and visible, Draco winds its way right in between them. Okay, see that? That's Draco. It's just a really nice, easy way to find Draco. His head is off screen, but you get most of the dragon.
It's in between minor and major.
Mm-hmm.
By the way,
both, it's way.
Go ahead, finish.
Oh, I was just going to say, if you can see both of the dippers in the sky, it's just a really nice locator. That's all.
Mm-hmm.
Okay,
Anyway,
Pat did a look up on Polaris, and the current value is 433 light years.
Okay, thank you. It takes Polaris AB 30 years to go around Polaris A.
Huh. One of them's a giant and the other's size of our sun? Or do they know?
I don't believe I put that statistic in here, the size of Polaris.
But it does pulse regularly, slowing down or speeding up over the years. What do they say?
It's here's an artist rendition of the triple system. That and here is the light curve for Polaris over December 2019. And the thing is, you see it's tilted here. So it is slowly brightening, but and you can't tell the period, but the period is slightly, the period goes through increases and decreases. A few years ago, there was such a severe decrease that the speculation was that it was going to stop being a pulsating Cepheid. But the people noted that it goes speeds up and slows down on a 30-year basis. So now the speculation is that it's the tight companion of Polaris AB, that comes in and interacts with the outer layers of Polaris A's atmosphere. And it's the pulsation, it's the expansion and contraction of the upper layers of the atmosphere that give it this Cepheid variableness. And it's connected very tightly to the brightness.
Well, I remember Tom Whittemore gave a great speech years ago to our club about Cepheid variables. So why are they different from a variable star, or are they a variable?
It's a particular class of variable star. The ones I was looking at Westmont through the 24 had really short, cycle times on the order of handfuls of hours. So you might have several cycles, maybe even 4 per observing night. So you get a lot of good data. You get a ton of data, and then you know, deconstruct it.
Okay, well, the sine waves on the screen, Jerry, they're going up, and that means the brightness, right?
Yeah,
That they're higher on the right side than the left. But the variations, are those months, years? Let's see, they're months, aren't they?
It looks like 4 days.
yeah.
Oh, 4 days.
See,
Yes,
there's a
days.
minimum at December 10, and then at December 14, you're just past another minimum.
Right.
So
Looks
that's 4
real
days.
too, huh?
Wow.
So anyway, Polaris is 0.66 degrees away from the pole of rotation as of 2018.
Okay.
It makes a circle 1.3 degrees in diameter, and it will be closest to the pole about 0.45 degrees soon after the year 2100. So what's that, about 70 years from now or 80 years from
Yeah.
now?
Hmm. Well, I don't want to open up a whole new subject, but didn't William Hubble back in 27 discover the constant about everything going away from each other by seeing Cepheid variables in Andromeda?
Right. Yeah. He was working off of the knowledge of women.
Yeah.
And that didn't have to do with the recession. That just gave him the distance.
That's right.
Oh,
The
to the
recession
Andromeda
was Vesto
galaxy.
Slipher doing the spectra.
okay,
Yeah.
so the redshift is what gave him this going away.
Yeah.
The back in the 20s, the issue, or before the 20s, the issue was, is our galaxy the entire universe, or are there other galaxies out there?
Oh,
And he was able to spot a Cepheid variable in the Andromeda galaxy. And because they already knew about the relationship between the brightness change and the period, he was able to determine the distance to the Andromeda galaxy, and it clearly resolved the issue that we are not the only galaxy in the universe.
Right. And, you know, I was going to mention, Jerry, that when he did that, that star, you know, it's pretty dim. I think it's, I don't know, 17th magnitude or something like that. And Andromeda is coming towards that. So it's actually a blue shift. So that was a blue shifted galaxy. But he got the distance off by a factor of 2. But so what?
Before he did that, the phrase for the Milky Way was an island universe.
and Messier gave it an M number thinking it was inside our galaxy, right? Andromeda.
But he didn't. Yeah, he just didn't know, Ron.
Yeah. It was just fuzzy and it was in the sky.
Right.
And somehow out of the billions of stars inside a galaxy that's what, 2.5 million light years away, he spotted a star.
Yep. Well, he had a 100-inch telescope with a camera.
And you can tell that it's, so I guess they're rare, right? Otherwise,
Not
they'd
that
all
rare.
they're not like binaries. There's more binaries than non-binaries, right? And trinaries, in other words, multiple systems. But Cepheids are rare, right? 1 out
I
of 10.
wouldn't say that, Chuck. Oh,
I don't think they're super rare, but they're
No.
rare among all stars.
yeah.
Well, do most stars pulsate?
A lot of Cepheids, Ron, have periods in the ballpark of, you know, upwards of almost a year. I mean, they take a long time, you know, and the longer they take, the brighter they are innately. Okay. But they represent a standard candle, you know, a distance locator. If you can measure the frequency of the pulsation, okay, you have a knowledge of how far away I'm sorry, how bright they should innately be, and therefore how far they probably are away from you.
Okay, well, this is how mankind has been navigating for thousands of years, having an orange tree. And
That's a tricky overgeneralization. The Polaris has not been our North Star for thousands of years. These conspiracy theorists that point out that the pyramids are aligned with the North Star, there was no North Star when those things were built.
Well, there was one, but it was called Thuban. It was in Draco.
Yeah.
In Draco the Dragon.
Yep.
Really?
Yep.
So after the pole moves away from Polaris in the 21st century, it will pass close to Gamma Cephei. It will also, by about the 41st century, that will be the North Star or close to it. And by the 91st century, Deneb will be the pole star.
Now that changes because the Earth wobbles slowly, but over time, that
Yeah, precession of the equinoxes is what causes it,
Mhm.
or is another symptom of it.
and that has nothing to do with changing the pole, the polarity.
No, it
No.
has nothing to do with our
It's-
magnetic field.
Got
Yeah,
it.
it's wobbling, Ron.
That's why I'm on board, gentlemen. I'm the one that learns.
You see Thuban there, Ron?
Yeah, I see it.
Yeah, that's like 2,600 years ago, right?
Yeah, it's about 3,000 years ago, 2,600.
Mhm, mhm.
So that would be about 1,000 years BC. That would be the North Star.
Mhm.
Okay.
And supposedly the pyramids were somewhere around this period or earlier. There was no real noticeable North Star.
Well, how in the world could they be aligned toward one star? They're all pointed straight up from the
Well, they
Earth.
aligned the chambers, when they buried the pharaohs, they aligned the chambers because they thought that that's where you would go after you passed
Yeah.
away.
Oh, I see.
There's actually a shaft in the big
Yes.
pyramid
Right.
that points toward Thuban, because that was where your soul would go up and travel to the unchanging star.
As opposed to those solstice shafts on the shortest and longest days of the year. Even
It's
Stonehenge
similar.
does
It's
that.
similar.
So by the
Yeah.
time the Egyptians launched their pharaoh spirits at Thuban, by now when it's getting there, they missed.
What's to come? What's going to be future North Stars? Did you mention that and I missed it?
Yeah.
Yeah, here we have going back into the future, 2,000 years away from now, 6,000, 8,000, 10,000, 12,000, 14,000. We're getting close to Vega. And then we can keep adding up 15, 16, 17, 18, 19.
Wow.
So
Well, if our
And
planet,
just to make this a little more confusing, Ron, there's also something called nutation,
Yeah.
where this isn't a nice circle. It's actually a little spirograph pattern
right.
of a spiral that's following this circle.
Right.
a spiral.
Oh, there's a faster deviation in where the pole is pointing that happens over short periods of time. So that makes us look like a curlicue going around the circle.
Yeah, Ron, the technical term is a wiggle.
Ribble.
Well, then why are they posting this circle in front of us here?
To simplify it so that
It's very simple.
Get the principle.
Because if our rotational axis follows that circle, our planet really is wobbling.
Oh, yeah.
Probably all planets do, I guess, in the solar system and all stellar systems, maybe. I don't know. Everything's turning, isn't it? Interesting. So how many years? 1,000 years, 2,000 we've been using Polaris?
Not very long. When Christopher Columbus went across there, I don't think he had the benefit of, In 1492, Christopher Columbus had to correct for the circle described by the pole star around the pole.
Well, at our
And,
December general meeting, we're going to have a little 20-minute talk from one of our members, Rex Meach of Ojai, about celestial navigation and the sextant.
Okay, good.
He'll probably talk about. Now, this is the potato chip galaxy, I guess you might want to say. Are they
This
shaped like
is,
that?
well, because the Cepheids are such an accurate, as Tom pointed out, such an accurate candle of distance, and the range that they're useful in is in our galaxy and in our nearer galaxies. Farther away than that, you can't really pick out individual stars. But this one group has looked at quite a number of Cepheid variables in our galaxy, and they've decided that our galaxy looks very much like this with us here, based on the Cepheid variable, the distance away they are. They actually get a 3D map for the first time. So you can tell altitude and distance, all three quite accurately, within about 5%, they claim, which for astronomy is very tight. And this is the distribution of, the one on the right is the distribution of measured Cepheids that were presently observed in the Milky Way. And you can see them sometimes right across the whole galaxy, because the galaxy is warped and these things stick up, so they're not blocked by the central bulge. This is a simulation of where they expected to find Cepheids.
So
And
Cepheid, so they're scattered on one side of the galaxy, not the other?
those are just the ones we can see, because the rest of
Oh.
the galaxy blocks our ability to see it.
Got it.
And
The color there is an estimate of their ages.
Huh. Well, here's a question that I know we've talked about Cepheids and the variable stars that fluctuate. Might it be a simplified way of saying that the war between gravity and the merging of the atoms, fusion, one of them starts to take over and then the other pushes back? Is that how they fluctuate like that? Why they?
Yes, very much so.
That's the reason.
When they expand, their layers cool and it changes the opacity, and that changes how they interact with the radiation coming out, and so you get this sort of breathing that goes on.
So the gravity starts taking over and pushing everything in, and that makes everything hotter. That then turns around and pushes out
pushes
again.
it back, yeah. At a certain stage in the life of stars.
Got
As
it.
Chuck pointed out, the red points here indicate older Cepheid variables, while younger ones are shown in blue. So you can see the older ones are out in the rim worlds, and we are right here in this white dot surrounded by little black marks.
Well, gentlemen, I'm assuming we're not orbiting a Cepheid variable, and it's probably a damn good thing we aren't.
Yeah, I don't think Cepheid variability is in our sun's future.
If it were, what would happen? Would it engulf us and then go back down, and we'd become part of the sun?
You'd have to go to a higher grade sunscreen every 2.5 days.
Good line, thanks. Fascinating stuff. Okay.
Anyway, the total number is about 2,400 Cepheids here, and they did detailed measurements over 6 years and recorded that the indicated distortion from the previous slide.
You said 2,000 out of
2,400.
Well, that makes them very rare. I'm sorry, but that's nothing compared to the billions.
That doesn't mean that's all there are. That just means those are the only ones they measured.
Okay. But if they have planets, exoplanets around them, there's probably no life on them, I would imagine.
Yeah.
Okay.
Okay, well, here we are at 10 o'clock in the evening. Neptune is below the circlet,
Aha.
our
Oh,
farthest known planet.
opposition. That
Yeah.
means furthest from us.
It's the furthest planet, farthest out, since
I know, but what is
Jupiter
that?
or Pluto got demoted.
What does opposition mean again?
Opposite the sun, it rises at sunset and sets at sunrise.
Which also means it's at its closest for the year.
Closest to us.
Yeah.
For the year, yes.
Okay. In other words, we're both on the same side of the sun.
Yes.
And if
Now
you
it has a slightly elliptical orbit, and so do we. So it may not be the closest it ever gets, but it's the closest for the year.
Right.
well, in deference to the name of our club, 29 AUs happens to be 2,697,000,000 miles away. Not light years. Thank
No,
God.
it's not that far away.
Light hours, like
Light
3
hours.
4 hours.
So Neptune was photographed by Voyager as it went by. And since then, we put up Hubble and now James Webb, and have been able to take more detailed pictures of it. It does have, this is the path of it through, in Chuck's favorite format, path of Neptune through by, what's that one? 5th magnitude field star. Remember this, it's HD 15313.
Henry Draper number.
Yeah. So it does have storms on it. It's less dramatically colored and turbulent, you might say, than the surface as Jupiter or Saturn. But it does have storms and cloud. This is a detailed picture of their clouds.
And the winds are the strongest in the solar system, like 1,200 miles an hour.
Yeah.
God.
So it's 17 times the mass of Earth and 4 times as wide as our planet. So there is a range between our planet and Neptune that's called super Earths that bridges that gap in exoplanets, where you're not 4 times as wide as our planet, but like 2 times as wide.
Huh, but it's mostly gas. There might be a big.
But I don't. These are called ice giants. I don't recall. They do have a rocky core, I believe. We'll have to go into that one time.
Okay,
I don't think we know enough to know, because we used to think that for both Jupiter and Saturn and found out that they don't.
Well, if they got winds of 1,000 miles an hour, that's mostly gas moving. It's not ice, is it?
Oh, Ron, astronomers call methane and ammonia ices, no matter what phase they're in, solid, liquid, or gas. They're called ices.
Really? Ice does not apply to frozen water then.
Hey, if they can get away with calling carbon a metal, then they take liberties with other terms also.
I see. Okay. And it's not Neptune, but it's Uranus. It's on its side, so it rotates regularly.
Yep.
Your direction of travel a while ago, I'm not sure if I can express this, but I always thought all the planets that were out from us, the gas giants and Mars, would be going toward the left. Or is that shown going to the right?
No, we all go around the racetrack the same way. When it appears that something's going backwards, that's called retrograde motion, and it just means we're passing them up.
That was my next part of the question. Okay, we're outdistancing. It is going that direction, but we're going faster.
Yes.
Got it. Okay.
And whether it goes around one way or the other depends on whether you're looking at the solar system from the top or the bottom.
Well, the inner planets would be going mostly, when they're on our side, the other direction than the outer planets, wouldn't they?
No, they go back and forth.
Well, okay.
Or they appear to go back and forth.
I
They all go the same
got the
direction.
concept down. I understand. I know what retrograde is.
Okay.
Fascinating.
So moving on to the other comet, now that Nishimura is too close to the sun, and we don't know if it's going to survive to come out the other side or not. It's not super close to the sun, so it's probably going to be okay.
Yeah, I had no luck, Jerry. I was up morning and Tuesday morning.
Yeah.
And I had no luck finding it. Yeah.
And the
So
constellation.
we still have 10th magnitude comet, not as bright as Nishimura, but it is in Auriga right now. I put the word Hartley right about where it is.
This is Hartley 2.
Yeah, Hartley 2. Yep.
Nishimura was Hartley 1.
No, that has nothing to do with Hartley. Nishimura was Nishimura. Hartley.
Oh, okay. So this is the Hartley.
Yeah,
Or is it the second one that astronomer Hartley has discovered?
that's it.
Ah, interesting. 103P, was Nishimura one of those? 103Q or 102, or what? Did it have a number?
Well, Ron, the P here is different from in other things. In asteroids, that's usually an indication of what part of the year they were found in. But the P for comets means periodic, or C just means non-periodic.
And how long does it take science, astronomy, to find out how long their whole track around the sun, just based on, or can we? We know how much, how often Halley's comes, every 76 years?
Three observations spaced properly is enough to give you the orbit.
Okay, so do they know Nishimura already? And this one, do they
Yes.
know how long? Some of them take thousands of years, don't they? Others go by in a few months.
Yeah,
Yeah, one of
periodic
them
comets
came
are
by-
defined as something like less than 200 years or in that
Okay.
neighborhood.
Fascinating. And I think we learned that maybe some of them originate in the asteroid belt, not Kuiper, not Oort cloud, but asteroids.
They can originate anywhere.
Wow. Well, an
They're
asteroid.
all sitting there orbiting the sun, happy as a clam, and something goes by very quickly, and it whips them out of their orbit into a new orbit that brings them to the inner solar system. And where they had mountains made out of frozen nitrogen and ammonia and water ice. The sun now melts all that, and it starts streaming off in a trail. And so that becomes our comet, or a bearded star, as they used to call it.
The ones in the asteroid belt don't seem to paint a picture like that. They're all dry rock to me. Maybe you're right. Maybe they do.
They've lost all they're within the sun's domain, and they've lost their volatiles.
Ron, the biggest asteroid is Ceres, and it's basically a big snowball. So
yeah, it's covered inside. It's lost all its surface stuff. But
well,
it's
that would be an interesting comet to see if it was ever kicked out of its orbit and went inward. What's this?
Well, that'd worry me.
Yeah.
So this target here is around NGC 1778. There's two very faint open star clusters up here. One of them is 1778. So in the region of Hartley, if you can't find that, you can find these open clusters. The open clusters, let's see, this guy would have been fainter as a group of, it's about 7.7 magnitude. Hartley eventually could reach 7.5 magnitude next month, but right now it's 10th magnitude.
And this is early morning because you can see the Hyades there. So that's Taurus. So this is pre-dawn or, 2 a.m., something like that.
Yes.
I'm sorry, Mr. President. I'm not sure if this was in your talking points. What is Hartley? It's a star cluster.
Comet.
It's the comet.
Oh, it's the comet. Oh,
Yeah.
Oh, yeah, of course. That's Hartley too. We're still on the comet. Does it have a tail? I guess
It does. This is a spacecraft, the what is it, Icron? Yeah, epoxy spacecraft went right up to Hartley 2 and took this photograph of it. It's got two massive areas with a bridge of debris here, and you can see different parts of the surface boiling off volatile materials because of its now proximity to the sun. This picture was taken in November 3 and 4 of 2010.
wow. It's another bowling pin. Interesting.
Yes.
So that's two rocks collided, two asteroids became one, got hooked in gravitation.
Well, probably two ice balls, but yeah.
And you're using my ice, not the one you were talking about, methane on Neptune, right? This is regular.
Nope.
This
We're
may well be
using-
methane too.
Yeah.
Wow. Well, on Titan, it flows in rivers and ponds and things, doesn't it? As a liquid. So, okay. Are we going to go to there?
Yeah.
Clear back to the clubhouse. Stellophane astronomy, I guess, had its beginning, at least as far as clubs like ours, right?
Amateur telescope making with grinding your own mirrors and stuff was created or started in 1923 by a group of people in Vermont called the Springfield Telescope Makers Club eventually. And one guy figured out how to do, he's sort of the John Dobson of his day, was Russell Porter. And he figured out how to grind mirrors. And so he started teaching. He made a mirror grinding class at this place. And they officially formed a club on December 7th, 1923. This is their pink clubhouse on Breezy Hill in Vermont. And it has a meeting every year in the summer since then, 100 meetings so far. The idea is to show off your telescopes that you homemade. And they've had some fantastic innovations in these things.
December 7th, 1923, coming upon 100-year anniversary.
Yeah.
Yeah, I think one of our club members, Jeremy Schmidt, showed his scope, that he started in the workshop here, kind of put it together on his own later.
They have an elaborate website that covers all aspects and is the go-to source for mirror making and telescope design. So it's our major resource. And they have a series of books based on the publications in Scientific American. This guy here is Russell Porter. And God, I forgot. I don't know which. Albert Ingalls is in there. He was the publisher or editor for Scientific American. And they both were instrumental in starting this club.
Huh. One woman.
You see, he's holding a mirror, Ron.
He's holding
Looks
a what?
He's holding a mirror. It looks like maybe a 3 or 4 incher, something like that.
Yeah, Russell is.
Mhm.
He was he's the Tom Whittemore of Cellophane Club, or Tim Crawford. Wow.
He was an architect, an engineer, an Arctic explorer, and outdoor adventure person. He also is famous for a number of really good architectural drawings of the 200-inch Palomar telescope.
Mhm.
And he was part of the team that designed it.
Well, did they have concave mirrors in their telescopes back then?
Oh, yeah.
Yeah,
Matter of fact, where Chuck just was in Ireland, they have concave mirrors on the giant, 72-inch telescope, was it?
This was about 4
You're
years.
muted, Chuck.
Chuck, you're off. We can't hear you.
Yes, it was the Leviathan with a 6-foot mirror. I was looking for a picture of it if you want to see it.
Okay.
Wow.
When you get it, let me know.
Well, you had lots of pictures with this story in your talking points, Mr. President.
Yeah, but I didn't do the Leviathan because Russell Porter and the Springfield group wasn't involved in it. This is a glass mirror. He did, glass was the mirror making material of choice. When the Leviathan was built, it was a metal, get a fresh surface. Later, they figured out how to do it on glass, and that defined the surface. And then they went through a process of wet chemistry to deposit silver on the surface of the glass. And then after World War II, it was a much more durable coating to evaporate aluminum onto the surface of the glass. And that's what we use now.
Aren't most home mirrors, the one on your medicine cabinet, the one you use in your vanity, they're all glass with something on the back, right?
Right, but these are for surface mirrors, Ron.
Okay, so why do you suppose they don't make them for the public or consumers to take?
In the mirrors you have at home for your bathroom, the mirrors on the back side of the glass. Our mirrors on the front side of the glass because we don't want the light to be disturbed by the layer of glass.
Right.
So it reflects off the front. So our mirrors are more exposed to the atmosphere, and they eventually tarnish and get compromised reflectivity. They're not as bright. So we recoat them every, say, decade or something.
Right. But and so Ron, when we would send away our mirrors or physically take them, I used to live in the Bay Area, up to Bob Fees, who's up in San Carlos, just south of the city. He would evaporate very pure aluminum onto the glass that you fashioned, and then put an overcoat of SiO2, actually, so several different kinds of silicate, okay, to protect that aluminum from tarnishing, okay?
Okay.
And the aluminum layer is very, very, very thin. It's very thin, and so is the SiOX overcoat, but it does protect the mirror from tarnishing.
It takes 125 125 angstroms of aluminum to make a continuous layer. So you do 3 or 4 or 5 times that thickness, about 500 angstroms. And remember, an atom is about 3 angstroms in diameter, 2 angstroms, somewhere like that. So these are very thin layers, and the silicon dioxide overcoat is only a few molecular layers thick.
Yeah,
it's very thin.
It was always a treat for me to bring, mirrors for my students in San Jose. Their mirrors up to Bob's, basically his backyard, his house. So he would do this thing out of his garage. He built the chamber himself. He had a diffusion pump, okay, that would basically pull vacuum on the bell jar, but he didn't take advantage of cooling, okay, cooling the cold plate on it. So basically, he gave you pretty good vacuum just with a non-cold plate diffusion pump, okay? And he would, first of all, coat your mirror with 5/9 aluminum, 99.999% aluminum. And then after that, in the same chamber, okay, he would have these little beads of silicon dioxide that he would, in the vacuum chamber, basically heat up, and they sublimate. They completely go to a gas form inside the chamber. Everything in the chamber gets coated, including your mirror. Okay, so every now and then he would have to clean off the little sight window. He had a sight window on his chamber. He did all of this stuff himself. He's a really smart guy, and he's still doing it. Tim had his 8-inch mirror done fairly recently by Bob Fies, Fies. Okay, hey, he had a website called Alcoat, Alcoat. Alcoat, Al for aluminum.
Huh.
Okay, I have the Leviathan pictures if you want to see them.
Okay.
Go ahead.
Okay, Jerry, you'll have to let me share screen.
I thought I did.
Leviathan means like a whale, something huge.
Huge.
There you go.
That's a Leviathan. Good Lord, it looks like a castle
It is.
with a,
This is the backside, isn't it, with the scope behind?
wow. What's missing in this picture?
Oh no, these are two walls, and the scope's laying down because there's the cable to lift it up. Oops. See, there's the cable to lift it up. Oh well, you can't see my cursor anyway.
And now, is this part of is this part of cellophane?
No, this is
not really.
the Leviathan of Parsonstown. This is in Ireland at Birr Castle.
Oh, I'm
It
sorry.
was the biggest telescope in the world for several decades.
I was wondering
This is the
where that
back
was.
end.
Okay.
And
got it.
there's actually a little mini railway system because he had two large metal mirrors that tarnish relatively quickly. And so while he was refiguring and repolishing one, he could use the other. And this is the back end. Now I'm going to try to move along, but I keep, I'll have to switch back and forth. So let me go back.
Just wonder what that derrick is.
No.
There it is. Oh, that held the telescope. Okay. Or is that the same one? Jeez.
Yeah, this is just
the
looking
same
from
back
the other
view,
side.
but this is looking down along the north-south meridian. So basically that's a north-south line. And the way he would observe was he'd move it to different altitudes and then just watch as things came by.
Mm-hmm.
So this is the back end. You can see the tube down there, and then you can see this whole system here of pulleys and wires for changing the altitude of the scope.
Just altitude. They couldn't turn. Wow. Looks like R2D2 down in the middle. I'm sorry. Uh-huh.
Okay, now. Sorry.
Well, it's just, you need more pictures.
Yeah.
Phone.
And I've got a cat here that's not helping.
It's helping you out, huh?
Yeah. Okay, so let's get back to Burr here. Okay, here's the that was the back view. Here's a close-up of the back view. And you can see the big mirror box there. They've refurbished the scope and put in a glass mirror so that it's usable again, but it doesn't look like they've used it in decades, unfortunately.
So he'd go to the right altitude and then something would come into view for how long would he get to watch it before he loses it?
Well, for a couple of minutes, because he could kind of try to trail it a little bit.
Trail it left and right when the damn thing only goes up and down? That's
No, they
okay.
could move it left and right a limited amount, Ron.
Oh, they could.
Yes.
Oh, okay.
Okay, so here's the back end again, where they had the little winch there for pulling it up. You can see here they've replaced it with an electric winch. It used to be just a couple of guys with a big windlass that would pull on it.
I know that woman. Where have I seen her before?
So here's a little railway system that they had for moving the mirror in and out. And here's this little when they refurbished it in 1997.
72-inch.
And that was his drawing of the Whirlpool galaxy. It was the first time they saw spiral structure. 1845.
In deepest, darkest Ireland.
And there's the front of the scope. And you can see how there are these various platforms that you could go to depending on the height of the telescope. And this bit in the front could raise and lower also of this platform.
Hmm.
Not a place you want to try and observe when you're drunk.
Yes. And they did have a Newtonian focus put in. I think this was in the refurbishment. You should see the eyepieces. They are like, you know, people call Naglers holy hand grenades, but these things are gigantic hand grenades made out of brass.
Uh-huh.
So that was the front end of it. There is a mirror at the back end, and that reflects into something on the side that you look in.
There's a mirror suspended in the middle that brings it out the side.
Okay.
Ron, just a little historical note. This was the largest scope in the world until 1917, when the 100-inch was, dedicated. And that's the one that Hubble used
Okay, but
down in LA, up in Mount Wilson.
Yeah.
I think I missed the name of the guy who had this one. Is there one person we're talking about? One
Lord
class?
Ross.
Lord Ross.
Yeah.
Lord Ross. Is he
Oh,
considered a pivotal astronomer in history? Did he just
Lord.
Yeah, he's a famous sort of semi-professional astronomer.
He's more famous for building this big telescope than he is for any famous discoveries. He did see spiral structure for the first time, as Chuck points out.
And they have a museum. Pardon me. They have a museum that talks about some of the things he saw. And unfortunately, it's very poorly lit. I mean, they could learn from some of the displays at our museum. They need an astronomer to look at some of their data they put up. Like he was looking at Messler objects instead of Messier. They put an L in where the I should be, things like that. So they can do some work, but it's overall, it's a nice display.
So not only can't they speak English, they can't spell it.
Yeah. And here's some of the platform work to get up there.
Wow.
Uh-huh.
And I think originally he did not have it configured as a Newtonian. I think he just had the eyepiece mounted right at the outlet of the scope there, and you would actually tilt the main mirror to bring the beam to a focus right at the rim there. And then he would have the eyepiece held at the rim, and he would look in that way with his head kind of partially in the field of view.
Wow.
Well, you guys went back there in the height of September, but I'm looking at the map of the world. Ireland's on the same latitude as Canada? And so to go out at night, it must have frozen your garbanzos off.
It's warmer there.
Yeah.
It is?
Yeah.
We had 70-degree weather and sunshine while we were there, which prompted Duff to say we were in the wrong country.
Is that right? And these are the lenses. This is how you look. See?
This is the eyepieces here.
Wow.
And you could apparently switch between them. And there's Pat getting a view of the back end again. And this is just a little sculpture that was in the garden. The whole Burr domain is, I don't know how, it's a huge 70 acres or something castle, still owned by the same family. And they live there. And they were actually, I guess we can stop sharing now here and you can go back, but they were really into science and engineering. And if you've ever heard of Parsons geared turbines that are used in especially powering ships from the 1900s on into the 60s, probably, that was one of his descendants, Parsons, Earl of.
Okay.
And they have a river that flows through that domain, and they put in these turbines to generate electricity. So they had their own source of electricity and all kinds of chemical labs. And so they were really big in science.
Wow. Well, we know why you went to Ireland. I had one other question, a follow-up to what Tom was talking about, and both of you were mentioning the metal that you reflect. Obviously, the James Webb, which cost $10 billion, uses the most expensive metal that the rest of us can't afford on our mirrors, right?
It uses gold, and it's coated onto beryllium.
Oh my God!
Beryllium is the structural material of choice because of its thermal properties.
You have any idea?
And it's lightweight.
You know how many angstroms thick of that gold on top of that beryllium?
No, but I'm guessing it's probably 500 angstroms. Don't use angstroms anymore. So that's, let's see, what is it?
nanometers.
50, yeah, 50
Nanometers.
thank you, 50 nanometers.
And there's no professional telescopes you guys could buy for an outrageous price that are lined with gold?
Sure, you can. You can get your own line with gold.
But
Is
you
it-
wouldn't want to, Ron, because the reason they're using gold is because of its reflectance in infrared.
Right.
And we're
Oh.
down below an atmosphere that isn't going to pass a lot of that stuff. And
Yeah.
so you wouldn't get very good views.
But isn't it interesting that aluminum has two separate uses in the field of NASA rocketry and astronomy? One is ground up, it makes a great rocket fuel in the shuttle, and spread out on a concave surface, it's a reflector. It's just
Very
amazing.
reflective, yes.
I heard we were running out of it for automobiles and things.
Nope.
Is that, nope.
The other myth with running out of things is lithium for batteries for cars.
Well, I heard helium was short too.
Helium is a very scientifically important material, and we are running out of helium. We get it out of natural gas wells, and it just blows away. It's hard to contain because that's a little spherical molecule, and it goes through just about everything.
I think we could solve the problem if we could get cold fusion, don't you? Get all that hydrogen and turn it into helium.
Yeah.
Okay.
Okay, well, let's finish off. This is a telescope in the early days in 1920s
Wow.
at Stellafane. This is a very famous design that they originated. It's called a
Naismith? Is it a
no,
Naismith?
it's a Naismith's, but it's let's see, I've got it written down here somewhere.
The principle here is that the eyepiece position doesn't change no matter where you point the telescope.
Right. Isn't that a Naismith design?
It's very similar to a Naismith,
Okay.
but it's balanced this way for amateurs. See the counterweight that comes out here because the telescope is offset from the pivot point here. This plate twists around, and the eyepiece right here stays in the same place, it just points in different directions. And the telescope is put way down here, so makes it very heavy this way. So you have to put something up here to balance it. Oh, geez, I forgot what it is. But anyway, this was a very popular design in the 30s, and it takes a lot of casting expertise because these parts are cast to do it. It's not a real popular thing with amateurs these days. A Springfield mount, that's what it's called.
It's Springfield.
Yeah.
Well, that's the name of the town in Vermont.
Yes,
And that house is on top of Breezy Hill.
Breezy Hill. And the inscription says, "The heavens proclaim the glory of God."
You suppose they're a functioning club like we are?
Yes, they are very, very functioning. This is from a more modern thing. This is from the 70s. There's a lot of innovative telescopes and designs get previewed there. This is a 12.5-inch ball telescope. So people have made this in smaller form using bowling balls as the universal joint. So, and this is what's called the Porter Garden telescope. He made about 50 of these as a product line. It's a telescope. The 6-inch mirror is here, and it looks up. This is the secondary mirror that reflects that mirror's light into this eyepiece. It's obviously used in a dark site where you don't have to worry about keeping extra light out. One of these was donated to the Museum of Natural History.
Yeah, Jerry, the whole story is that there was a garden up in the Riviera where one of these telescopes was actually found, and they didn't know what the heck it was. Some of the parts were missing, including the mirror. So Tim fashioned the mirror, and Joe Doyle made a part of the telescope too.
He made a base down here out of wood.
That's it. Thank you,
Jerry. An ironic thing was when I first moved here in 1980, I rented a room from a fellow engineer out at Santa Barbara Research Center blah, blah, blah. His name will come to me in a moment.
Mhm.
Anyway, and he had a machine shop in his garage, which I like to tinker around with. But one day a friend of his came over and he had this, turned out it was the base for this telescope that later was donated without the base because they had been hired to clear brush away from an area of the yard to get rid of, to keep the fire danger down. And so he showed it to us. He says, this should be part of some instrument. And we all agreed it had Archimedes and Galileo written around the base and stuff, but it
Wow.
looked familiar, but I couldn't place where it was or what it was. So eventually he sold it for scrap.
Oh,
And then that was about 1980, 81. And then probably around 2005, the rest of the telescope was donated to the museum.
yes. Yeah.
But this thing was gone. I went back and contacted people that I knew were involved in that. None of them remembered that or knew where anything like it was. So
Well, this looks like it's
it had been neglected for quite a while. If you find one that's whole, they about 5 or 10 years ago, they were worth about $25,000 each. And there's a fellow in the East that does castings, and he made about 20 more of these from the original drawings.
I see. Yeah.
So,
And the way it was donated was there was an elderly fellow living up on Mission Ridge up there
Mhm.
who was cleaning out his garage. And he said, when I was a kid, my father was like a contractor, and he was working on this estate up along Mission Ridge up there. And in their garden, they had one of these scopes, but the people were the second owners of the house, and they didn't know what the thing was, and they didn't know what it was for, and they just wanted to get rid of it. And he was just a youngster. He was in like junior high, and he thought it looked pretty cool. So he grabbed it, the major structure here. He also had the mirror case. There was a little casing that the mirror would go in, but he didn't have the mirror. He may have had the mirror originally, but he didn't have the mirror by the time he donated it to us. And he said those things had been sitting in his garage for 70 years.
Wow. Yeah.
Well,
And I was going to mention, Jerry, that these are 6-inch f4s.
yeah.
So Tim crafted a beautiful mirror, and it used to be in a display box at the museum, and I just don't see it anymore. Do you, Chuck?
Actually, I heard it was in Luke's office.
I got to tell you, gentlemen, I don't see it. I don't see a barrel or anything. I don't understand how
Well,
that.
it's a tubeless.
Yeah, it's
You
open
need
air.
something to hold the secondary and eyepiece up here, and it works fine.
And that's definitely not Vermont, because look at the background.
Yeah,
Oh, those are the mittens. No, that's
Yeah.
those are the mittens.
Monument Valley, Utah.
Oh my
Yep.
God. Okay. Bring that up again next week, because we're going to do number 136 program. And this is fascinating stuff. I always learn, but then unfortunately, because of my age, I forget half of it. Let's do it again, gentlemen.
Okay.
Take care of yourselves and be ready. And I guess I hope we don't have to start wearing masks again, but you guys get
I
well,
don't know.
Chuck and
Yeah.
President Jerry and Tom.
Okay.
Take care of yourself, and we'll see you
Okay,
next
guys.
week for the